Hey, welcome back, guys. It's Mr. Sheeline. Here we're going to be going through our circle graph activity. This is going to be the third graphing activity that we've done, or at least separate, distinct activity we've done. So we've seen the notes, we've seen the line graph, we've seen the bar graph, and now we've got to work on the circle graph. So just a heads up, probably a good idea to pause the video here. Go grab a couple scratch pieces of paper or a notebook, because this demonstration is going to be a little math heavy, okay? Now, it's not any math that you aren't used to, and it's definitely not math that you cannot do. You will be perfectly okay, whatever level of math that you're at, you're going to be able to do it because it's super simple, okay? All it does is it takes you to remember percentages. It takes you to remember how to use percentages and put them into a calculator, okay? So, all right, and I've got my handy dandy whiteout because I will probably be making some mistakes in this, okay? All right, so let's take a look at this particular question. So let's see here. So you are an energy consultant and you want to know how much energy in quadrillion BTUs, okay, quadrillion BTUs, different energy sources used in the year 2009. You researched the data on this stuff and this is what you found. Coal used up 19.996 quadrillion BTUs. Natural gas consumed 23.416. Petroleum used up 35.242. Nuclear electric power used up 13.671. Hydroelectric used up 5.881. Geothermal used up 2.379, and biomass used up 8.328. Now, we don't need to know what each of these things are specifically, but what we do need to understand now is we need to understand what those are. And all those are different energy sources, okay? That's all they are. Natural gas, you've probably heard of. Coal, you've definitely heard of. Petroleum, that's just oil. You've heard of that. Nuclear energy, we've heard that's nuclear power plants. Hydroelectric is like dams. That's just water going over a turbine and making energy, more or less, while transferring energy from the water to the turbine. And then geothermal is using the heat and coolness, or the heat and the hot air and cold air from the earth to generate a turbine, to generate a generator. And then a biomass is like more, it's what it sounds like. Bio, like living material. Mass, just a big old clump of it. It's like dead leaves, it's detritus material, is all it is. And they burn it. So, all right. So it's important to know that these are all distinct types of energy sources, because we need to know how to break all this up. Because then we need to know how to answer these two questions. You know, what's the independent variable, what's the manipulated variable, and what's the responding variable, what's the dependent variable, okay? Okay, so let's now ask those questions. So what's the independent variable? Okay, well, the independent variable in this case, and this is where, you know, circle graphs are a bit strange, because yes, they still rely upon independent, dependent variables. They still rely upon manipulated variables and responding variables. They're just a bit different because they work with populations, or that they at least work with totals. And that'll make sense here in a second. But what doesn't make sense maybe at the beginning here is knowing the difference between the two, these two variables in this case, okay? Because we've got just energy sources and the amount of energy they use. How do we know which one's which? You can still ask the question, you know, what has an effect on what? Does the type of energy have an effect on the amount of energy used, or does the amount of energy used have an effect on the type of energy consumption or type of energy source? And obviously, of course, the energy source affects the amount of energy used and not the other way around. So I just basically gave it to you. So the independent variable, these are the different energy sources. Okay, these are the different energy sources. So then that must mean then the dependent variable. The dependent variable here is going to be the what's the best word? Amount. It'd be the amount of energy consumed. But now, remember, it's energy consumed, but in very specific units. Specifically in quadrillion BTUs. Okay, BTUs. Now, we could have done this too. We could have actually gotten rid of the 1, and we could have had it like this. We could have had it in quadrillion BTUs. We could have put it in parentheses. That'd be fine too. Okay, so we've got the independent variable and we have the dependent variable. Okay, so now we've got to create the data table. So for the most part, up to this point, this is going to be pretty normal, or sorry, up to the point in which we're done with the data table, this is going to be pretty normal. Okay, after that, then it's going to get a little math intensive, so just prepare yourself. Okay, so let's make our data table. So let's do the same thing we did last time. Ooh, but I see that our dependent variable, our responding variable, is going to be pretty long. So let's make this a little wider than usual. So let's go, actually, I think last time we went 3. Yeah, so let's maybe go 5. 1, 2, 3, 4, 5. Let's see, do you think that's enough? Let's go 6. 1, 2, 3, 4, 5, 6. Okay, and then 1, 2, 3, 4, 5, 6. Okay. Give us plenty of room, or at least more room than we've been giving ourselves lately. And let's start filling this stuff in. Okay, so we've got our manipulated variable. This is energy source. Okay, and then our responding variable is amount of energy consumed. And then we're gonna run out of room, quadrillion BTUs. Okay. So maybe we should have still made it a little bigger, but this will still work. Okay. So let's just now write these in the order that we read them. So first one was coal. The next one was natural gas. Next one was petroleum. The next one was nuclear electric. Next one was hydroelectric. Okay. Then it was geothermal. And the last one was biomass. Okay. So let's now just draw the line over here. I got that. And we can draw this line over yonder. Got that. And then our last line over here. Ooh, and I do not have a piece of paper sitting underneath this. Okay, here, give me just 1 second. Let me put a little something behind this just so my pen works a little bit better. There we go. Okay, and let's try that bad boy again just so it's nice. Yeah, there we go. Nice thick line. Okay. Let's keep on dressing this bad boy up. Let's keep throwing some lines. Now, I keep having to, for whatever reason, this paper is just really clumping up the end of my pen. If you've been wondering why I like twist the tip of it, it's because it just keeps building up a whole bunch of like paper gunk. It's actually kind of annoying. Okay. And then we can just do the rest of the lines, make it look pretty. And here you can start contemplating, you know, what was it that you did that got you at this point that you had to watch a video on a 27-year-old teacher, you know, showing you how to make a circle graph. Existentialism starts to settle in. You begin to question everyday activities. You begin to wonder how it is that you're still here. Okay, and then we've got our data table. Okay, now all we got to do is we got to fill this in. Okay. So let's see. Coal used up 19.2 996, not 999, sorry. Insert movie reference there. Okay. Now again, remember, we don't have to put our units in every time with these because we've got our units up here in parentheses in our header, so we don't have to worry about, you know, putting quadrillion BTUs after every single number here. Natural gas had 23.416. Petroleum used up 35.242. Nuclear used up 13.671. Hydro used up 5.81 or 881. Geothermal used up 2.379. And then biomass 8.328. Perfect. Okay. All we have left now is a title. Oh, let's see. What could we come up with a good title here? This is all on the spot, by the way. Let's see. What good title could we use? Amount of energy consumed per energy source. That would be a good one. Energy consumed per... I think I just said that. Let's just go with that one. Energy consumed in quadrillion BTUs per energy source. Okay, let me box that bad boy in. And then we've got our data table. All nice and neat, looks all pretty. Okay. Now remember when I said that, the circle graphs, you know, they're based on population, okay? Well, if they're based on population, if they're based on totals, what we have to do now is that we've got to now add all of these values together, because what we want to do is we want to find a total. How, out of all of these guys, what is the complete picture here? How much energy was used by everybody? Okay, so what you can do is you can just then take, I'm not going to write each number down. Actually I will. I'll do it on this paper though, just so it's a little easier to read. Okay. So, and then we can write it down, and then we can use our calculator to plot it all together, but we need to do this. And where did it go? Oh, there it is. So we need to do this. We need to do 19.996, 23.416, 35.242, 13.671, 5.881, 2.379, and then 8.328. We need to add all this together. Now, of course, yeah, you don't have to do this by hand. I won't subject you to that, but let's plot this into a calculator real quick. So 5881 plus, maybe here, I'll do this so you can maybe see it. Yikes. Trying to get a good spot where you can read where the light isn't putting a terrible glare on my calculator. Okay, so I almost forgot. Decimal there, 18.671, 35.242, 23.416, and then 19.996. So we should get 108.913. Okay, that's what I got there. So if you got that, good. Okay, so we should get 108.913. So what that tells us now, for full context, that tells us that out of all of these guys that we've recorded, out of all of these types of energy sources, the amount of energy, we just added them all together, and total, out of everybody here, the total was 108.93 or 913 quadrillion BTUs. Okay, so maybe I should do that too. So write the units along with this guy, because that's what it is. It is 108.913 quadrillion BTUs. So, and the reason why this is important is because it gives us context of what we're doing. It gives us it helps us better understand why it is we're doing what we're about to do. So we've got our total. Now what we've got to do is we've got to find the percentages of each. We got to find the percentages of each energy source. Okay, so let's find out what those percentages is. So remember, when we're trying to find percentages, there are a different number of ways you can find this. The best way you can do it is that you take your oh, why can't I think of the word? What you do here is that we're going to throw here, this is going to be a fraction, and every single time you're going to put your total. In this case, it's going to be the total energy. You're going to put the total value on the bottom, and you're going to put your, let's say, measured value up top, okay? Your chosen measured value, okay? You put that up top. And then what you do, because this is going to happen first, and then you multiply it by 100, okay? You multiply it by 100, and then you would get your percentage. So let's take a look at, let's do one of them. Let's do the first one. Let's do the 19.996. So it'd be 19.996 over 108.913, okay? And then times 100. So first we're going to divide 19.996 by 108.913, okay? So let's do that. We're going to do no glare. 19.996 divided by 108.913. Okay, and we're going to get this weird decimal. Okay, you should get a weird decimal. Okay, and then what's left to do is now you got to multiply that by 100, and you get your percentage. So let's go, because everything is sticking with 3 decimal places. We're going to stick with 3 decimal places. So we got 18.359. So, quick little lesson on rounding. Now, I'm not going to ask you guys, I'll be picking better examples for circle graphs with more like whole numbers, where this won't be an issue, or shouldn't be an issue. But for rounding, if we're going to go to 3 decimal places, we need to look at the 4th decimal place, that's 6, and we have to ask ourselves, is that number greater than or lesser than 5? If it's greater than 5, we're going to round up the next number. In this case, it's 9. So we're going to now bump that 9 to a 10. And because it becomes a 10, it's going to throw a number, or it's going to throw a 1 to that 5. So it's going to be 18.360. Okay, and that's a percentage. 18.360. Okay. And again, that is the percentage we got. That's the first percentage. That is the percentage of, and let's maybe keep track of this. That is for coal. So maybe off to the side here, let's do, coal. Coal is 18.360%. And now we're going to do that for the rest of them, okay? So 23.416. So just follow along with me doing this. 23.416 divided by 108.913 times 100, that's going to be 21. Oh, lovely. That's okay. That throws a 1, that throws 1, it's going to be 500. So then our second one here, that's going to be natural gas. It's 21.500%. Okay. 35.242 for 108.913 times 100. Now, if you want to skip, if you've already got this, or if you want to skip forward, go ahead. I'm going to keep going, doing what I'm doing. Also, because since I'm using the little Elmo thing, I can't pause the video. I'd have to completely stop recording, and I'm not going to do that. So here we got 32.358, and that is for petroleum. Petroleum 32.358%. Next number 13.671 over 108.913 times 100. Now, if you have any questions about this when we come back from the weekend, please ask me, okay? Because I'm sure either you guys have never done this before or it's been a long time since you've done this, okay? It's important that we remember how to make a circle graph. Okay, so this 12.552 is nuclear. Yeah, that's nuclear power. 12.552. Okay. Then the next one is going to be 5.881 over 108.913. What could I talk about in this? I could maybe talk just about how, like, I'm actually pretty excited for, you know, the end of October here. So I've been wanting to buy a, I've been wanting to buy a really nice PC, but I've just been building my apartment basically. Money's been just a smidgen tight, but we're getting quite a bit done with it. And yeah, I'm hoping to have a really nice PC. Like, for those of you, if you know anything about PCs, if you know anything about video cards, like, I'm hoping to put in, you know, an NVIDIA 2000 series video card in. Because I think the 3000 series just came out last month, so we're gonna have a nice souped up little computer here. Let's see, geothermal. Sorry, I'm losing track of my thoughts here. Oh, and I watched the debates last night, or the first debate last night. If you watched that, that was interesting. Political commentary, am I right? Ha 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 ha. Let's see, 2184. Oh, we're almost done here, guys. So that's 2.184%. That's how I keep writing them up here just so we have them. Because these are going to be important, okay? These are going to be very important. And then finally, 8.328 over 108.913 times 100. 8.328 divided by 108.913. Okay, and last but not least, biomass. It's going to be 7.65%. Now, just to double check that we've got these numbers right, or it's at least close, we can add these together. Ooh, what did I do? Shoot. Hold up, sorry, let me double check something real quick. Oh, it should not be 6.5, it should be 6.46, sorry. It should be 7.646%. All right, so let's add them together, because when we add these together, this should equal to 100. Okay, 18.360 plus 21.5 plus 32.358 plus 12.552 plus 5.4 plus 2.184 plus 7.646. Now, it's probably going to be over 100 just because we rounded up, but let's see what we get. Oh, we get perfectly 100. Awesome. So, remember, because we found the percentages of a total, the total being 108.913 quadrillion BTUs. And we found the percentages by just dividing against the total, taking our whatever particular, you know, energy source, its amount of BTUs, divided by the total BTUs, multiplied by 100 to get our percentage. Okay. So we need to keep this data because we're going to use this on our graph. Okay. And we also need it in order to make our graph. Okay, so I'm going to hold on to this, but I'm going to go to a new sheet here. I'm going to go to a new sheet. Let's see, where's my mouse at? There it is. Okay, we're going to go to a new sheet here. All right. Now on this new sheet, actually, I'm going to tear this guy off just so I can see it at the same time. So those weird decimal places that you got, we need to use those. So just the way that you can get back to those weird, the way you can get back to those weird decimal places, you can just do this. You can, so 18.3360 would just be 0.18360. Then it would be 0.21500, 0.32358, 0.12552, 0.05400, 0.02184, and then lastly 0.07646. Okay. So these are the decimal places that we need to now find our angles. So because the circle graph is a circle, we need to now think of what a circle is made of. Well, a circle, remember, and you can even see it here in your protractor because it's literally half a circle here. Okay, your protractor is half a circle. Okay. Well, in degrees, what's half a circle? Well, in degrees, half a circle is going to be 180. Okay. So from here all the way, from here all the way over to here is 180 degrees. Okay, well, if we had two pieces, 180 plus 180, okay, 180 plus 180 is going to give us 360 degrees. Okay. Well, if we know a circle, a full circle, and that's the shape of our pie graph, our circle graph, if we know it's 360 degrees, all we have to do is we have to now multiply these weird decimal places that we found. We just have to multiply 360 degrees by these percentages, okay? Because if we're fitting all of the information of the energy source, of the energy consumed, into a circle graph, we got to fit it all in there. We've got to chop it up proportionally, right? And how do we do that? Well, we know that there's 360 degrees. We multiply that by their percentages, okay? Because this will give us the degree that it's going to be, I guess, projected at. It's the best way of saying that, projected at on our circle. And we'll see what that looks like. So let's just do this. We're going to take these and we're going to multiply them by 360. Every single one of them. Okay, 360 times 360 times 360 times 360 times 360. Okay, and this will give us our degrees. And maybe we should do this, 360 degrees. This is going to give us our degrees here. Okay. And remember, you've got to use the decimal. You don't want to use the 18.360 because it's going to be off by 2 decimal places. Okay. Oh, times. So this guy's going to be 66 point. We're going to keep them to. Well, let's just see what we get. Let's just see what we get at the end here. We'll just keep whatever your calculator plops out. Let's just write that. Okay, 77.4. Remember, these are in degrees. 0.32358 times 360. 116.4888. Okay. 0.12552 times 360. 45.1872 degrees. 0.05400 times 360. 19.44. 0.02184 times 360. 7.8624. 0.07646 times 360. 27.5256. Now, we've got to round these up or down because there are too many decimal places here, and we just can't count those decimal places at all. So let's just round to the closest whole number. So just to the closest whole number. So because there's nothing after, it's 66.0 and then 96, this guy's just going to be 66 degrees. 77, and because that 4 is not greater than 5, it's just going to be 77 degrees. Okay, 116.4, we're just going to keep that 116 degrees. This one's going to be 45, 19. This one's going to be 8 degrees, and then he's going to become now 28 degrees. Now, let's just real quick, let's add those up. What number do you think we're going to get? 66 plus 77 plus 116 plus 45 plus 19 plus 8 plus 28, and we get, well, of course, we're one short, 359. So we are, you get 359, just one short of 360. We lost, just because some of these were rounded down, we lost just a single digit, but for the most part, all of these angles add up to 360. And 360 degrees, remember, is a circle. So now, oh boy, I know this is a lot, guys. If you need to take a break, remember, you can always pause the video, step back, and then we'll come back to it. So now we've got our degrees. We also have our percentages here. Remember, we've got these percentages and we've got the degrees. Now all that's left is we just have to make our circle. So now the size of the circle doesn't matter. It really doesn't. What does matter? Oh, there it is. What does matter is that you just have something that looks, like a decent circle, something that looks like a circle. So you can use, if you've got a template, or if you've got anything that is a circle, like a cup, or I've got this little thing of hand sanitizer here that I'm going to use. Use it as a stencil, okay? Now, ideally and typically you want to line up with the grid, but we're just going to have it on the grid here. So just take this, take whatever you're using. If you've got a compass, use your compass. And try to make a nice looking circle here to the best of your ability. That ain't too bad. And then we can get going. All right. So now that we've got that, roughly speaking, just because we're going to be eyeballing this a little bit, we're going to try to find the center. Okay, don't need a ruler for that. Now there is a way you can use a ruler to find the center, but let's just eyeball it the best that we can. And it looks like to me, this looks like the best center I can get. Okay, that's probably the best center. Now what I'm going to do though is I am going to use my ruler here, and I'm going to draw. This is going to be my starting line. That's my starting line there, okay? And that starting line is going to basically start my first degree, okay? And my first degree, remember, is 66 degrees, okay? So what you do is that you are going to take your protractor and you're going to lay your protractor on this line. So you notice that this flat side of your protractor, you're going to lay it right there, right against your line. You are then going to follow this number here, the 10 to 20 to 30, and you're going to find 66. And it looks like 66, we got 66 right there. You're going to put a little mark right where 66 is at. Then you're going to take your ruler. You're going to match up with that little dot you just made with the center of your center dot right here, and you are going to draw a line from there to there. And you now have your first section of your pie, okay? And then pretty much all you got to do is rinse, repeat. The thing you got to remember though is that you've got to put your protractor on every new line that you put down. Okay, so the next one is 77. Okay, so 77, it's going to be 75, 76, 77. There's my line right there. Oops, sorry. Boom. Okay. Next one is 116. There's 100, 110, 120. And so it's a little bit behind. There's 116. Big old chunk right there. Next one's 45. Okay, 45 degrees. It's right there. Next one is 19 degrees. Okay. Nice. 8 degrees is the next one. Right there. And lastly, we should end up with 28. Oh, and of course, why am I off so much? Oh boy, why am I off? Where did I go wrong? Here, let me figure out where I went wrong. I don't know where I did, but I did somewhere. Let's see. Where did I go wrong? Where, oh where? Oh, of course, right here. This is what I did wrong here, so that's my bad. So I accidentally went to 56 rather than 66, and I didn't double check my work here, so it's pushed everything back by about 10 or so, actually quite a bit more than that, so shoot, that kind of stinks. How to fix it? Actually, instead of having to redo everything, we're going to just redo the starting line that we have, okay, and we're just going to do this, because then we just have to change one line, okay. Now this time, since we're going this direction, we got to make sure we're using these bottom numbers here. So we're going to go to 66 this time. Okay. Okay. And then let's double check that again. I've got 38. I must have messed up somewhere else. Let's see what this is. That's 20. That's 19. That's good. This guy right here, that's 45. That's good. Maybe it's the 116. Did I mess up on the 116? Maybe I went 126. Let's see here. Nope, that's 116. Okay, did I mess up on the 77? I did. I messed up on the 77. I went to 67 rather than 77. Ooh, how to fix this one then? Oh boy. All right, bear with me here, guys. This is all a learning process. That's my bad. I wish I could go back and change it, but this is all part of learning. Okay, let's just do this. Let's redo these lines just so we don't have to do all the lines. All right. So, oh boy. So hopefully you were, if you were already doing it correctly, and notice I did this wrong, good on you. If, however, you were doing this correctly and now I'm making you erase all this, I'm sorry. Double check your work real quick. Just make sure that you did it right, better than I did. If you are as wrong as I am right now, I apologize. Very, very, very much, I apologize. Let's make this guy 28. Let's just make this guy 28. So, because we know this one's 28. So we gotta get rid of this line too. Okay. And let's just keep on going. So let's do that 66 again. 66. Okay. There's 66, now 77. Let's see, 70 and then 75, 76, 77. Oh, this one could have stayed. That's a bit aggravating. Now let's double check that 116. That 116 is still good. All right, now we've got everything. We should. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, now we've got everything. So that's my bad, guys. Okay. And again, if you caught this while I was doing this and you already had the correct angles of your pi, good on you. Bad on me for making that mistake. So now, all that's left is pretty much presentation. So we've got our angles, we've put them in, we've got our percentages. Now let's put in our percentages. Let's dress this up. So, okay, now it's important to remember which one's which. So we started with coal, and then we worked our way around to biomass. So this one's going to be coal. So we're going to write in coal, and we're going to write in its percentage, which was 18.360%. The next one's going to be natural gas. So natural gas. And natural gas had 21.500%. And then we had petroleum. Let's see, sorry. Petroleum. And petroleum had 32.358%. Next one is nuclear. Nuclear had 12.552%. And then, let's see, hydroelectric. Now, this is where it's getting a little cramped in here. Probably for these next three, we can do this. We can just move our graph over here. We can just draw a line. And we can write it outside of the, oh, not hydrogen, hydro. Sorry, goodness. Full of mistakes in this video. Hydroelectric. Hydroelectric is 5.400%. Draw a line here. This is going to be geothermal. And geothermal is 2.184%. And then lastly, we have our biomass. And our biomass here is 7.646%. Okay. And then all we have left to do with our pie graph here, our circle graph here, is we just now have to color it. Now, when we're coloring it, best advice, you want to go warm color, warm color, cold color. So meaning you don't want to have these kind of colors together because red, orange, and yellow are all warm. You really don't want these guys together. Green's kind of the exception, but you don't want these guys kind of linked together because these are your cold colors. You maybe want to arrange them, every other. Okay. So there are my colors, and let's just color this in. So coal, let's just make coal brown. Oh, let's just be quick about it. And it's always great to have color in your pie charts because it just makes it pop. It makes it look good. It makes it look presentable. It just makes the percentages. It makes the proportion of your pie graph, of your circle graph. It makes it just that much more appealing and pop out to the reader. Easier to read, that sort of thing. Okay. And there you have it. You have your good old classic pie chart. Okay. Now again, I know this one is running pretty long. So thank you for sticking through with this, guys. I hope to see what you guys come up with, what kind of colors you use on this graph here. And if you still have questions over this, like if you have questions like how did we come up with all these numbers? How do we know how to get these percentages again? How is it that we can find our degrees? Where did this come from? If you need me to answer those, if you need me to answer those questions, please get a hold of me, send me an email, talk to me during class on Monday, on Tuesday, Wednesday, whenever you can talk to me, because this is super important, because I am going to ask you questions on, percentages for pie charts or on circle graphs on the test, which again is going to be coming up here in a couple weeks, or at least for you guys in 2021. That's true. Things might have changed if you're watching this after this particular year. So anyway, okay. So that's it. That is making a pie chart. I keep saying pie chart. That is making a circle graph, sorry. If you guys have any questions, please get a hold of me. If not, it's fine. If you want to subscribe to this channel, please subscribe, just so you know when I post videos. If not, that's okay. But in any case, I will see you in the next video, guys. Have a good one.